guys, welcome to another series on integral calculus. In this series, we are going to look at some of the techniques in integration, and I hope by the end of the series, you will be able to master integral calculus very well. Without wasting time, let's get started. So, today's concept is antiderivatives. In this lesson, we will learn how we can find an unknown function if we know its derivative. So, let the known derivative be small f at x, and then the unknown function is big F at x. So if big F prime at x gives us small f at x, then the big F at x is called the antiderivative of small f at x. So what this implies is that if you have a function represented as capital F at x and another function represented as small f at x, and when we find the derivative of the big F at x, and that gives us the same thing as small f at x, then we can say that the big F at x is the antiderivative of the small f at x. Definition: a function big F at x is said to be the antiderivative of the function small f at x in the interval I if and only if big F prime at x equals small f at x for all x in the interval. So this is the definition of antiderivative. But note that if big F at x is an antiderivative of small f at x, then big F at x plus a constant c is also an antiderivative of small f at x. The most general derivative of f on interval I is big F at x plus c. So all that you are trying to imply is that if a function, say big F at x, is said to be an antiderivative of another function small f at x, then whenever we differentiate the big F at x, it gives us the small f at x. Simple. So in other words, like we are trying to say that this is the original function, but when we integrate this function, we get this. But when we differentiate this function, we get this. Example: if big F at x equals 1 on 3 x power 3 is an antiderivative of the function small f at x equals x squared. So if this is the antiderivative of this, then we can say that f prime at x, that's the derivative of big F at x, will give us the same thing as this. Let's see. You know that when we are trying to find the derivative of a particular function, we take this one, multiply by the whole thing, then we take 1 from the power. So when we simplify this, get rid of this, hence we are going to get x. When we subtract 1 from here, we're going to get what? 2. So it means it's equal to x squared, which is the same as f at x. And notwithstanding, if we add any constant, say c, to big F at x, the resulting function also becomes an antiderivative. When we add any constant to this and we differentiate, we get the same answer. Let's see. So assuming the same thing, maybe 7. Let's find that and see what we are going to get. The same thing. This comes 3.1 on 3 x cubed minus 1. When you differentiate this, anytime you differentiate constant, you get 0. When you differentiate, you are going to get f prime at x is equal to x what? Squared. Let's take some examples. The problem says show that f at x equals x e power x plus pi is an antiderivative of a function f at x equals e power x bracket 1 plus x. Let's see how we can solve this. We know that if the function big f at x equals this is said to be an antiderivative of the small f at x equals this, then we can say that big F prime of x is equal to small f at x. Now, what is our big F at x? Big F at x equals to x e power x plus pi. So our f prime at x equals, so this one from basic differentiation, you know that this is a product, so we are going to apply the product rule. So product rule says that we should maintain one and differentiate the other. Anytime we differentiate an exponential function of this form, we get the same thing. So this is the same thing that we're going to get. Then plus, now we're going to differentiate, we are going to maintain this, that e power x, and differentiate this. When we differentiate x, we're going to get 1 plus differentiate the constant, that's 0. So when that happens, we are getting x e power x plus e power x. This will give us the same thing, plus 0. The 0 will go. Then you can see that our f prime at x is equal to, we can factorize the e power x out, and that will give us x plus 1. And you can see clearly that that's the same as f at x. So now we can conclude that since the big F prime at x is equal to f at x, hence f at x equals x e power x plus pi is an antiderivative of small f at x equals e power 1 plus x. So this is how you show that a particular function is the antiderivative of the another function. In this particular series, I will take you through all the various techniques in integration. Stay tuned, keep on watching. Please subscribe, share, and like for more videos. Thank you very much. Bye bye.